Here we go. And this presentation is called Humanizing the Math Experience. And to recap the wonderful introduction that Sean gave, I am Dr. Randy Polysock. I have been in education for 23 years at the elementary, middle school, high school, and at the college levels. And I am one of the founders of Synergy Academies, which is a nonprofit that runs 3 schools in South Los Angeles. One is an elementary school, a middle school, and a high school. And after running the schools for 10 years, I decided to leave the schools that we started to go into curriculum design, because I noticed that with the textbooks that we were using with our students, it was written in a way that didn't really make sense to the kids. So we did have to end up rewriting a lot of the lessons to make them more accessible to students. So I decided to leave the school that we started to go into curriculum design and publish all the lessons that we have been created, that we had created at our schools. So I've written a series of 10 math fluency books under the Core Advantage name. And I'm also a professional development specialist. And yes, I am currently a 6th grade teacher at James Jordan Middle School. So that's a little bit about myself, and I'd like to get to know you as well. So would you kindly open up the chat window, and in the chat window, type your name. I think it actually already appears. Type in what part of the world you're calling in from and your role in education or whatever field you are in. So go ahead and take a minute to type in the chat now. And let me go check out the chat. All right, welcome Colleen, Annaline, welcome. Kathleen and Sophie. Great, someone's been teaching for 30 years. Great, we have a psychologist in the house. Welcome, welcome. So go ahead and continue to do that because I'd love to get to know you. And let me put the presentation back up. All right, so this session again is entitled Humanizing the Math Experience. And here are some questions for you to ponder. Number 1, why is there such a huge stigma around mathematics? Number 2, why do people label themselves as either a math person or not a math person? And number 3, which is the most important question that we need to answer today, is why are there so many memes like this floating around the internet? So this is one of my favorites. This is the confused math meme. So here we go. So that's one of the famous memes that's out there, and it really captures how a lot of people are confused about math. And whenever there's an online discussion, even if it's not related to math, people love to use this meme. And another one of my favorites, I hope the sound came through for you there. Did it come through for you, Sean?
Yes, we heard it. Perfect. Good old X-Files theme. We know that well.
That's what makes this one of my favorites. And another one of my favorites is this one here. I remember watching this when I was in high school. This is from The Simpsons episode 1, or season 1, episode 2. And it first aired January 14, 1990. So over 30 years ago. And this is when Bart cheated on an exam and got placed into a school for the highly gifted. So here's the example.
So y equals r cubed over 3. And if you determine the rate of change in this curve correctly, I think you will be pleasantly surprised. Oh! Well, don't you get it, Bart? Derivative dy equals 3r squared dr over 3, or r squared dr, or r drr. Hardy har har. Get it?
Oh, yeah.
So poor Bart is in this classroom, and these elementary school kids are learning calculus, and he's completely out of place. And that look on his face.
So y equals r cubed over 3.
That look on his face when everyone gets the joke and he doesn't, that was actually me in college calculus. So I don't know about you, but I never took calculus in high school. It wasn't offered at the school that I was attending. So when I entered college, I was required to take a calculus class as part of my business major. And when I signed up, I thought, okay, they'll probably take it easy on us because we're business majors, we're not math majors, and we'll get an easier version of calculus, and which was I was looking forward to because I'd never taken it in high school. And it turns out that was far from the truth. You actually needed to already know calculus in this class, and they were just using applications of it in the business world. So that was me in college calculus, and that was the worst semester of my life. And as soon as I failed my first test, I had to think of explanations that I was going to give to my parents about why I dropped out of college and didn't even make it past one semester. So I did end up passing the class, and I learned how to get the answers. But even after leaving the class, I still had no clue what calculus was. So that confused look, I think a lot of students feel that way about math, and not just older kids about calculus, but kids in general about math in general. And there's this huge stigma about mathematics, and a lot of kids feel like they don't belong. And during this session, I want to explore why that's so and what we can do about it. So in my opinion, one of the reasons I think there's a stigma around mathematics and why people feel like they're not math people is we've been teaching it as a dehumanized subject. And the question is, how have we dehumanized math? And my answer to that is that we've forgotten that math is a human language, just like English, Spanish, or Mandarin Chinese, because it allows people to communicate with each other about the real world around them. And in fact, a famous philosopher by the name of Galileo once said that the laws of nature are written in the language of mathematics. But somehow we've taken this language of math and have abstracted it far beyond recognition, and that's why a lot of kids are so confused. And to give you an example of that, this is a third grade standard here in California where I teach, and it says, understand a fraction 1 over b as a quantity formed by one part when a whole is partitioned into b equal parts. Understand a fraction a over b as a quantity formed by a parts of size 1 over b. And if you gave this explanation to an 8-year-old, this is probably the reaction that you would get from them. And to a math expert, this explanation makes perfect sense, but if we approach it this way with our students, it'll make absolutely no sense to them and will only cause confusion and frustration. So the question is, how can we teach concepts like fractions to students, but in a simple way that actually makes sense to them? And the challenge that I want to look at first is a 5th grade challenge. The challenge is how to add and subtract fractions with unlike denominators, which on a scale of 1 to 10 makes how much sense to students? 0. It makes absolutely no sense to them. And the reason this doesn't make sense to students is because they don't know about numerators and denominators, but they do know about apples and apples. So start there instead. So when I'm teaching 5th graders about adding and subtracting fractions with unlike denominators, I always start with the apples plus apple lesson, which here's an example of it. And we start off with 1 apple plus 1 apple. And a lot of times students will respond as 2 with the answer to this problem. And it's partially correct. So we should remember that math is a language. It's a human language, so we should include the words in it as well. So it's not just 2. Insist that the students respond as 2 apples. So here's the next one. What is 3 pencils, 2 pencils plus 3 pencils? And you all know that pencils plus pencils give you pencils. How many pencils? We have 5 pencils. Things get a little interesting when we get to box C. So here the question is, what is 3 pencils plus 2 cars? And students will look at this problem and say, Dr. Polysock, that doesn't make any sense because pencils and cars aren't the same thing. How do you add them together? So I tell the kids that they're exactly right, that it doesn't make any sense, so we cannot add them together. In order to add things together, they have to have the same name, like apples and apples or pencils and pencils. So attempting to add pencils and cars makes absolutely no sense. So we cross it off during the lesson. Then in the next word, we get to those confusing fractions problems. But to clear students' minds, we spell it out in words like this. What's 1/3 plus 1/3? And when you present it this way, now students can use apples plus apples as their analogy. Realize that thirds plus thirds give you thirds, and the total here is 2/3. And notice how much more effortless that is. Things get interesting again in box F. So they're presented with 1/2 plus 1/3. And again, students look at that problem and say, Dr. Polysock, halves and thirds aren't the same thing. We cannot add them together. So of course, we cross it off. Now when you take these same two fractions problems and write them in fraction notation, the logic makes a lot more sense. So in box G, instead of spelling out 1/3 plus 1/3, we write it like this: 1/3 plus 1/3. And the logic is still there. So just like apples plus apples give you apples, thirds plus thirds still give you thirds. How many thirds? 2/3. And students are able to arrive at the sum without having to understand what a numerator and denominator is. And now imagine what happens when we get to box I and students see this. Here's 1/2 plus 1/3. Again, they'll say, Dr. Polysock, halves and thirds are not the same thing. We cannot add them together. And I say, exactly. So we cross off this problem. And you might be wondering, how do students know that you can't just automatically add them together when they don't know about numerators and denominators? Well, they're not using numerators and denominators. They're using their intuition instead, which is a lot more powerful than any rule that you can come up with. The last row is the most important row. So in box J, we have the problem 1 apple plus 1 banana. And of course, we know that this makes absolutely no sense because apples and bananas are not the same thing. They don't have the same name, so you cannot add them together. So we cross off that problem. But in box K, we put that very same problem on screen. And I explained to the students, 1 apple plus 1 banana, I know we can't add them together because they're not the same thing. But what if you had to find a way to make it work? And without fail, someone in the class will say, Dr. Polysock, they're both fruits. And I say, exactly. So why don't we rename them? Instead of 1 apple plus 1 banana, let's call them 1 fruit and 1 fruit. And now it becomes obvious that the sum is 2 fruit. So there was a way to make this problem work. All you had to do is figure out what the objects had in common. And you've just laid the groundwork for common denominators. So now when we get to box L, the most important box of all, we put up that same problem that didn't make sense earlier, 1/2 plus 1/3. And I challenge the students and I say, we know this doesn't make sense to add them together because halves and thirds aren't the same thing. But boys and girls, what if you had to find a way to make it work? And there is a way, and we'll learn how to do it in our next lesson. And I actually have conducted this lesson with older students, with teenagers who are just entering high school, who had struggled with mathematics throughout elementary and middle school. And one year, when I did this lesson in the 9th grade, and we got to the part about covering this in the next lesson, one of my students, Ashley, goes, no, Dr. Polysock, tell us now. So she was so intent on making sense of this problem that she didn't want to wait until the next day to figure it out. And when you can get to that point, it's like having a checkmate in math because students are no longer running away from math, but they're demanding to know how it works. So this lesson to me is a giant chess match. And do you remember my opening move in that chess match? what was my very first move? It was right there in box A. 1 apple plus 1 apple. And at the time, it seemed so trivial and so meaningless. But what I was really doing was thinking ahead, and I already knew what the winning move was going to be. So my strategy for this lesson was to remember that math is a human language. We can humanize math by putting the language back in there and including the units and including the words. And that way, once students have gotten a hold of the concept, now when you start abstracting it later on, it makes a whole lot more sense. So here's an overview again of that lesson. So you might be wondering, well, do you ever, during the lesson, talk about numerators and denominators? And absolutely, that's something that students need to know. So when we do talk about numerators and denominators, let me show you the way that I go about doing it so that it makes a lot more sense to students. And let me switch over to my document camera, which I've grown to love during online learning. Makes life so much easier. And let me pull this up. And here we go. So the very next page in the lesson, this is the actual apples plus apples lesson. When we get to the next page, we help students understand what numerators and denominators were, but we do it in a natural way that uses language to help them. So if you take a look at the term 3 apples, one part of this term is a number, and the other part is the name of the objects. So 3 would be the number. Apples is the name of the objects. Now take a look at 5 pencils. One part is a number, and one part is a name. 5 is the number. What's the name of the objects? The objects are called pencils. Oops. So these are the names. Now for the third one, look at 1/3. And here is a physical representation of that. So one part is the number, the other part is the name. 1 is the number, tells you how many you have. And the other part is the name. That is the name of the fraction. This, boys and girls, is called a third. Now when we write it like this, instead of spelling out 1/3, we write it in fraction notation. One part is still the number, and the other part is still the name. So 1 is the number, tells you how many you have. And boys and girls, what is the name? And they'll often want to say 3, but I remember that it's not pronounced 3, they're pronounced thirds. So third is the name of the fractional piece. And in California, a lot of my students speak Spanish, so I incorporate that into the lesson. So I say to write the Spanish words for number and name. So the Spanish word for number is número, and the Spanish word for name is nombre. And in number 6, it says to write the math words for each part of the fraction. Well, boys and girls, the number on top, that is called the numerator. And the number on the bottom, that is called the denominator, which seems like completely foreign words. Denominator. And in number 7, if you notice, it says circle the roots to show the connection between numero and numerator and nombre and denominator. The first one's pretty obvious. We can see that they both share the word numer. Numer in numero and numer in denominator or in numerator. And it turns out that numer is the Latin root for number. So numerator just means number. The second part's a little harder. Nombre and denominator. They don't look like they have any connection whatsoever. But if you look closely, you'll notice that nombre has nom, and denominator also has nom. And it turns out that the Latin root for Nom, that means name in Latin. Let me write that down. So denominator, that just means name. So this is the number of pieces involved, and that's the name of the fraction, the fractional piece that you're working with. So numerator and denominator simply mean number and name. And that's why when you see a fraction like 1/2 plus 1/3, you cannot add them together, not just because they don't have the same denominator, but because they don't have the same name. And that's why you cannot add them together. So when I explain what numerators and denominators mean to my students, I connect it to language so that I'm not just throwing these math terms around to them that don't make any sense to them, but I'm showing them what they actually mean, and then they're able to use that to help understand math a lot better. And then in subsequent lessons, we learn how to change names properly, just like we did when we changed 1 apple plus 1 banana into 1 fruit plus 1 fruit, which allowed us to complete that operation. So let me switch back to the other screen. So let me finish up this section here, and then we can open up the floor for questions. So I believe that if you humanize the math experience in this way, it makes math a lot more accessible. It turns students onto math a lot more than treating it as a completely abstract concept that students are not able to understand. And Sean mentioned that I used to work at the high school level as well. It's one of the schools that I started, actually. And I had the privilege of working with struggling students, teaching them lessons like this, and finally having them understand things that they had been totally confused about from elementary to middle school. And it really does have a human impact on them. So I'd like you to meet Jocelyn. This is one of the students at the high school. She was one of the students at the high school that I started. And I got her permission to share her story with you on Facebook. So you're going to get a little peek into my Facebook account. And this is my account of her. It says, "Meet Jocelyn, one of my all-time favorite Synergy turnaround stories. Jocelyn came to Synergy for the first time as a 9th grader when we opened our new high school. Like many of Synergy's new students at the time, she struggled to pass algebra because she was missing a lot of basic math skills. This was a problem because if you can't pass algebra, you can't graduate from high school. I remember going into the classroom and working with Jocelyn and her classmates on a daily basis to get them caught up on the basics that they never mastered when they were younger. She was a student who always showed great appreciation for all the extra help she was receiving. As a result, she improved tremendously, passed algebra, and moved on to higher level math. She was also a student who got especially upset with me when she found out I was leaving Synergy in 2013. I remember her exact words to me, "Mr. Polysock, you can't leave. You taught me my times tables." I was caught off guard that of all the things this teenager could have brought up, she specifically mentioned times tables. To us, it seems so trivial to mention learning times tables, but to Jocelyn, it was a matter of dignity because she couldn't handle the algebra coursework without it. I'm so proud of her because 4 years ago, you could have considered her just another inner city kid struggling to survive in school. But now you can call Jocelyn a senior class president and proud high school graduate on her way to a 4-year university in the fall. Mission accomplished. So that's one of my favorite stories to share. And Jocelyn is an example of how when math is inaccessible to students, it really does affect them at a human level. And it really was a matter of dignity. And when math finally started to make sense with her, it brought out the best in her. She was able to become senior class president and got accepted into a 4-year university. So that's an example of how when we humanize the math experience, it really does have an impact on people. So I'm going to go ahead and stop the presentation here. And there's so many more examples of how we can humanize the math experience. And I'd like to hand back the floor over to Sean to help moderate a discussion.